Okay, yeah, hello everyone. Welcome to this webinar. It's another episode of the DataBri-X webinars, the tool session number 5. And today we will explore additional tools powering the DataBri-X use cases. And information in the beginning, this session is recorded. So if you don't consent, then please leave. In the beginning, we always give an overview of the DataBri-X project. So the objectives of DataBri-X are to build a user-friendly toolbox of practical, robust, and scalable bricks, which are processes, technologies, and tools to support the data lifecycle in compliance with FAIR principles. The toolbox can optimize regarding criteria like the energy footprint, and connects to data spaces, initiatives like IDSA and Gaia-X. And we also support the reuse of existing ontologies, vocabularies, and data models. The DataBri-X toolbox architecture is governed by a process called JenPlane. So the JenPlane data governance is a process, but also applications. We will see details for that today. And JenPlane can be used to design processes, to assemble workflows from the tools. It will take into account the optimization criteria like power consumption and optimize this automatically. JenPlane can be used to run these workflows using monitoring, orchestration, and data space connections. In DataBri-X, we have 3 use cases which come from different domains. First, the operator data space. It's about optimizing business processes of a telecom operator, improving the services and reducing the costs. The energy data space is a use case about energy communities where we optimize the data processing for simulation of energy grid behavior. And finally, the legal data space is about providing applications for insights into legal documents, helping legal experts with their work based on a legal knowledge graph and intelligent recommender services. The tool presentations that we will have today are 2. So first, we will look at the TripleGEO tool presented by Harry, which is a tool for transforming geospatial data into RDF. And this tool enables seamless integration and semantic enrichment of geospatial information for advanced data analysis and interoperability. And the second tool or tools that we will look at are specifically the JenPlane applications which implement this governance process for the DataBri-X toolbox. So a very central component of the platform we are building. And there is the designer and the composer. So with the designer, you can develop custom processes using shared templates, export these processes to the deployment compiler, and the composer lets us generate Docker configurations for process instances, deployment, and to manage these complex workflows. And with this, I would like to hand over to Harry. So thanks for joining and looking forward to your presentation about TripleGEO.
Thank you, Robert. So, I'm Harry Nakos. I work at the Athena Research Center, and today I will be presenting to you TripleGEO, a tool that was developed in the Information Management Systems Institute of the Athena Research Center. So, what is TripleGEO? TripleGEO is a command line tool. It is open source. And its purpose is to extract features from geospatial files and databases and transform these features into RDF triples. It's an open source tool, and the source code is available at GitHub. What does TripleGEO work on? And what functionalities does it have? The main features of TripleGEO is transformation from geospatial datasets from various formats into RDF. Also, it is able to do the reverse transformation from RDF to de facto conventional formats for geospatial data. For the former part, the input that TripleGEO may receive could be in CSV, in JSON, GeoJSON, shapefile, and more formats that we will be seeing also later. TripleGEO can also take input from spatial databases like the PostGIS extension of Postgres, Oracle Spatial, and more. The output in these cases, in all cases, is RDF. And there are two main features that make this output possible. The one feature is mapping from an attribute schema into an ontology. The attribute schema refers to the thematic attributes and also the features of the input data. And the second feature is classification of input attributes into categories based on a classification scheme. We'll be seeing more of this also later. The reverse transformation takes RDF as input and produces CSV, GeoJSON, or shapefile output. How does this work? It works by constructing a graph from the RDF data and then applying a Sparkle query on the data, creating records that have a geometry attribute and also the required thematic attributes that together reflect the underlying ontology of the input RDF data. Some other features that TripleGEO has is the ability to do parallel transformation of multiple datasets that have the same schema and configuration settings. It does so by partitioning data files that are provided to workers, to concurrent workers to work on them. And also TripleGEO supports the distributed transformation of geographical files into RDF using Apache Spark and GeoSpark, the geospatial extension of Spark. The list of supported formats are shape files, GPS exchange files, GeoJSON, OpenStreetMap XML and binary PDF, CSV and JSON, GML and KML originally by Google, and various geospatially enabled database management systems like Oracle Spatial, Postgres, as we already mentioned, MySQL, Microsoft SQL Server, DB2 with the spatial extender, Spatial Lite as the spatial variant of SQLite, and also geodatabases in Microsoft Access format. The RDF serialization supported are RDF XML, the more readable RDF XML abbrev, and triples, notation 3, and turtle files. And the geospatial representations that are used for the features are the GeoSparkle standard for all features available, like multi-points, multi-line strings, and multi-polygons. and other vocabularies, the geoposition vocabulary or the Virtuoso RDF vocabulary, which is a legacy. The GeoSparkle is the most used. So how exactly this transformation work? This TripleGEO has the two functions as we mentioned. It's the extractor and the reverse extractor. The input that the extractor receives is a configuration file that drives the transformation. The input type is defined in the configuration file, the exact file type or the spatial database type. Then, depending on this value, the input info is provided, file paths when a file type has been defined, the driver for the database if a database is used, and the database credentials to use. And yeah, the most important thing that is provided in this configuration file is the mapping specification for converting the attributes to RDF, and the classification specification for using a classification scheme. For the mapping, the RDF mapping language or a YAML specification may be used. The RML is very, very expressive, but the YAML is easier, the YAML spec is easier to use and define. We'll see an example of the latter one. And regarding the classification spec, a CSV file or a YAML file may be used. We'll see an example of that also. And as for the reverse transformation, TripleGEO is executed with the reverse extractor parameter, and the configuration file is also provided as an execution parameter. In this case, we have one or more input files, RDF triples files, and also a Sparkle select query that is applied to the RDF graph, the constructed graph, and the resulting records of the select query are persisted in the defined output file type. Well, regarding that, it is assumed that the user knows the underlying ontology of the RDF graph, and this is, of course, needed in order to construct the Sparkle query. So we'll be describing a small example now. This is an example of the transformation of a GeoJSON file into RDF. Here we may see the GeoJSON file. It has a few attributes, non-feature attributes, like the OSM ID, an identifier, a timestamp, a name, and a type. This list, this is a collection of features, of point features. And then, of course, there is the geometry, which is a point geometry with a longitude and latitude coordinate. This is a standard GeoJSON format. Then we have the configuration from the transformation that receives, that defines, first of all, as we may see somewhere in the 1/3 of the way, the input files, which is one of the input files is this GeoJSON, the formerly shown GeoJSON. The serialization format is defined further. The ontology for the geospatial ontology then, and then we define the mapping specification and the classification specification. If we go back a bit, we'll see that we have the bus stop as something, as a type, a POI type that will make use of a classification scheme. And yeah, that's regarding that. Then here, as we said, the mapping specification defines this file used for the mapping. It is a YAML file. This is the most interesting file that drives the transformation. If you look closely at it, you have the lowercase keys that define parts of the input dataset, the attributes of the input dataset, while the uppercase fields define entities, RDF entities. The first part defines how the URI is constructed for the main entity, the RDF entity, regarding a specific feature. And other entities are created and linked using the predicates to this parent entity. Also, built-in functions may be called to transform more rudimentary, to construct more rudimentary data types that are linked to the aforementioned RDF entities as well. Regarding the classification, here a CSV file is used that shows the hierarchy that is used in this dataset. Here we have you may see points of interest as the main category, and public buildings, recycling center, restaurants, schools, shops as the subcategory. Or you may see the road main category and cycleway, footway, path as the secondary categorization part. And finally, here you may see the resulting dataset, the RDF dataset in n-triples format, where you may see the links, the main link, the main entity, and then sub-entities that are linked using predicates to the main entity. That's all from me. Well, this is not the time for questions. Questions will come at the end. And thank you for listening.
Many thanks, Hari. Really interesting presentation and a great way to transform geodata. So questions, yeah, we will take at the end. And we will continue with the next presentation of Javad and JenPlane.
Sure, let me share my screen here. So hopefully you see my screen.
Yes, works well, thanks.
Okay, great. So hello everybody. My name is Javad Chamanara. I'm a project lead and also a research group lead at TIB, which is the Leibniz Information Center for Science and Technology in Hanover, Germany. Today I will be here with my colleague Rohit Gupta. I will present the conceptual design and architecture and also a little bit about the purpose of the JenPlane itself with its main components. And then Rohit will take us through a live demonstration of one of the, let's say, scenarios that we can support, how to design a process, how to select tools for that process, and how to actually build a workflow and execute the workflow. So JenPlane in general is basically a way to design a process. In this case, we have come up with this solution of having a Cartesian process definition, which you see there are two axes here, x-axis and y-axis. X-axis is basically the maturity of the delivery, so that when you start a project, especially a data-intensive project, you start with like experimenting with your data, with your theory, with your tools, and so on. Or if you have any analysis method, you will do this conception phase to come up with a potential solution. And then after that, you will implement the solution, like, for example, analyzing your data, checking your hypotheses, and so on and so on. And then when you reach to the maturity of your solution, potentially you want to publish the results. And then at the same time or after publishing, you will need to also to preserve your methods, for example, your papers, your data, your outcome, and so on. So this is the x-axis. On the y-axis, as you see, there are something called disciplines. These disciplines are basically the working area. So we have anticipated that if you run a data-intensive project, you will need to somehow categorize your work into any of these 8 or possibly a little more disciplines, so that, for example, you do data acquisition, you make sure that data fits to your purpose, you describe your data, potentially you do analysis on that. If you are getting data from multiple sources, you need to do some sort of data integration and so on. If you don't know what data you are looking for, you may first go to discovery of that data and so on. And then also in the whole process, you will do some planning and plan execution and this kind of supporting work. So for each of these working areas or disciplines, we have designed smaller activities like this yellow boxes here. There is an extensive list of these things that you can choose from the governance process application later on. Will be shown that you choose from that, put them on the surface here, and basically you design your process telling that what you want to do to achieve your result. And then based on this, we will help you to select tools, services, and operations from our DataBri-X tool set, so that you know how to realize or automate all these activities, how to link them together, how to establish like a data flow between them, and also potentially how to optimize all this flow for energy consumption or for speed, for example, and so on. So this is the conceptual model of the governance model. And then we have put this into an architectural perspective. In this architectural perspective, you see on top left that someone as a process designer will come and design a process. And then based on the use case or based on the scenario that they want, they will try to optimize this process for either energy, cost, size, or duration, or anything that we support. At the moment, we support energy and cost, but adding the other ones will be also on the plan. So, and then based on this optimization objectives, there is a recommendation system behind the scene that will recommend from the tools that you see here on the left bottom. It will recommend which tool will best fit the activities that you want to do in the process. And if you agree on those things, it will do a parameter matching, checks everything, and then it will create a workflow for you in the middle part with this deployment manager part or the deployment part. And then when you are okay with the workflow, you can basically execute that workflow on an execution system or runtime system. For the workflow building, we are using Argo workflow. And for the runtime system, we run this Argo workflow wherever that Argo can run. But our suggested runtime environment is Kubernetes, because all of these tools that you see here on the screen are containerized. So they are standalone containers, which we actually make data and control flow between them in the workflow, but we cannot force them to run on one machine. So it's possible that each container runs on different machine. So basically here, Kubernetes helps us to transparently deploy all these containers onto available machines establish the link between them so that they can reach each other, they can find each other, and they can communicate. And then we run the workflow on top of that facility that Kubernetes provides to us. So with this, there is an application. I'm just showing the main concepts here. Is a web application that is implementing JenPlane. So here we define 5 different things. Organizations means that organizations are working with JenPlane, organizations that are using JenPlane, or organizations that are building the tools. So all this organization will be actually registered here. And then we have the processes, which basically means that we are putting some best practice templates here so that you can load them as a template and then customize them for your own purpose, which are then projects. So basically you create a project based on a template that is in the processes folder. And then every user or each user that is working with the system, regardless of organization, process, project, or tools, should be registered here with permissions and so on. The other part is that the tools, basically this tool is a software tool wrapped into some REST APIs so that we register them here, extract information from the metadata of the tool so that we know what kind of services are available in this tool and how much each operation or each service of the tool will cost in terms of execution time or energy or really monetary cost. So based on that information that we extract here, later we recommend which tool is good for the data project that you want to do, and suggest you different services, different tools, or different versions of the tool that are best fitting your requirements. So with this, let's say that these are some organizations registered here. This is the form to register a new organization. And then with the processes, you can basically see here that you can upload a zip file. We don't go into the detail of this, but in general, this is an RDF representation of a process that shows you what activities are available, what kind of disciplines are available through this, and what is the default template if you want to start from that template. So basically, it's helping you to not start from scratch, but you are free to remove everything there and just start from scratch as you want. So, and also with the tools is that, as I say, tools are registered here. We support multiple tool versions, and then each version of the tool can have different services or different cost indicators for the similar services. So you can have, like, for example, one service like this TripleGEO that Harry said. This TripleGEO in one version can cost, for example, 10 watts, but the next version is more optimized. It can cost 6 watts of energy. So, and then we choose which one is good for the process that you want to actually to run. When all these things are done, then basically you create a project. Here you see that the project is based on a process version. And then you see this design area so that you can add your activities from the activity box on the right to the design surface in the middle, and then into different disciplines and different phases. When you are done with this, you go for the recommendation. Here, the objective is to reduce energy. And then based on that, you get some recommendations that you see on the tool with that circle with numbers in it. It means that there are 8 tools that can serve this task on the surface so that you can choose between them. And then here you can basically choose from the recommended ones. We tell you which one is the best, but you are free to choose any other thing. And also, if you don't like the recommendation at all, you can go with that custom button on top and then choose whatever service that you want, even if it's not optimized. So when you have these things, basically, then you are able to draw the flow, like these arrows between the tasks, so that we know that you have chosen the tools and services, and also you have established the flow between the initial step and the final step. And then at this time, you can basically compose this into an Argo workflow, like you see here. And then this Argo workflow can be submitted to an Argo runtime system like Kubernetes with Argo workflow running engine to be executed there. And then if you go to Argo, like here, this is the URL of the Argo endpoint. We submit it there, and then when it's there, basically you can see the execution and the status and the logs and the errors and whatever from the Argo admin panel. So that was a very quick review on this. And now I would like to ask my colleague Rohit to give you a live demo by creating a very simple project. Select the recommended tools, a flow, and then create an Argo workflow for that and also execute it on our own Argo workflow engine. Rohit, please, I'm stopping share.
Yeah. Can you hear me? Yeah. Okay. Is my screen visible?
Yeah.
Okay. Hi. Hi. Good afternoon, everyone. So I'm just giving the demo of the system. So this is the initial page of our JenPlane server, where we can see the number of organizations, the number of processes, projects, and the tools that are present in the JenPlane. So basically, if we go here, so we see we have right now 12 tools. So by clicking on the add new, we can actually add the organization, the details, and then we can see the number of organization getting increase here. I'm going there right now, but yeah, and these are the like this templates that we have given as Jawad explained regarding the processes. So right now, as you can see, there are 3 templates for the processes with the name DataBri-X Micro, DataBri-X, and DataBri-X Mini. For the DataBri-X Micro, we have 2 versions. And idea here is like this: once users click on DataBri-X Micro, they can actually go and see the number of versions and all the information, and they can click here and they can see what is there in the processes. And then yeah, same for the other things also, DataBri-X and DataBri-X Minis also. So there are different activities and then different tasks that we are giving to the users just to understand the system here. We also have, before going to the projects, I'm also want to go to the tools. So we have tools here. So here the idea is right now we have 3 tools, but the users can basically add the tool, and I want to just quickly show this thing, how they can do this thing. And there's a reason. So users can just provide the like the repo name and the token of their GitLab repository. So once yeah, my token is missing, but yeah, like if you provide the token and then click on the submit, then we can actually see the number of tools getting, and we can see actually what is there inside the tool. So by clicking here, also here in the tool, we can see the number of tools, the tools. If there are multiple operations, we can actually go and see the operations also. Inside the operations, we can see the operations, how many operations are there, and the details of the operations here. Yeah. Now I want to go to the projects here. So right now, let's say right now it's like okay. So first of all, we can actually create the projects. So for creating the project, it works like this. So yeah, let's say I'm creating the project with the name P1, and for the organization, so we can select the organization. Let's say I select TIB, and then the processes. Let's say so there are 3 processes because users can see the details of the processes, and then let's say I select Databricks Micro, and then the version, and then we have, if the multiple versions are there, then the multiple versions can be selected too. So there is some detail there they need to provide. We can go on project, okay, and then yeah. So let's once we click here, we can see the JenPlane designer view here. So right now this is the task basically. So this is some predefined task that we are giving to the user so that he can understand few things. But let's say, and on the right side, as we can see, there are few activities here. So user can, based on the requirement, they can drag the activities, and if something is not important, then they can actually remove the activities out of it. So then it works that way. Now let's say this is our activity with the name aggregate time series, and now we want to see the tools that have been recommended for this particular activity. So we, for this, we have to click on the recommendations, and then based on the objective we can optimize this thing. So let's say if it's energy, so we go to the get recommendation. So yeah, so you see, so they will be like the two recommendations that will be given to the user. So based on our recommendation engine that Jawad explained, so we are recommending DCC query. So there are two tools here, but also we can click on the custom if user really want to see their tool. So we can click on the system and see right now there are three tools, and then the RDF Pfizer was not given in the recommendation, but the user can actually select this thing and then it will appear on the top. And then they can also reset it, and then they can again go to this DCC query. So it works like this. Now, in order to create the Argo workflow, so there is a wiring system that we need to make. And so yeah, so this is the wiring. So here we can do the wiring, and then again it's like this. So this is just a sample scenario. Now this the wiring has been done. Now in order to see the Argo workflow, we have to click on the compose. Yeah. So we have clicked on the compose, and then this is the Argo workflow file. So now we can actually deploy it just by clicking on the deploy button, and then this is the URL. So we can so we can pass this URL here. Yeah. Yeah. So then if you go to the submit, then it will say that the deploy has been submitted, done successfully, and then we can see the number of steps. So this is the page where we can actually see. So we are replicating the Argo server page here, and then we can see the logs and everything also. So let me show you this thing also. You see my screen? Yeah, still I think. Yeah, so you see that this is executing and it can actually take some time, but yeah, so this is the case. We can go to the logs and everything, and then we can actually see the things there. Yeah. So like this is how to like submit, and this is from my side. Yeah.
Okay, thank you, Rohit. I guess we are done here. Back to you, Robert.
Okay, many thanks. Great presentation. Thank you, Jawad and Rohit. Yeah, JenPlane is a really important application for the DataBri-X toolbox because it implements the governance and workflows. Okay, I guess these are the presentations for today, and I would be happy to answer questions now, or Harry, Jawad, and Rohit answer the questions. So, do we have any questions? Okay, I have a question actually about TripleGEO. I was interested. I mean, if you transform data into RDF, RDF is a graph data format, and the atomic parts are URIs because it was intended to be published on the web, right? So if you do this transformation, I guess you need to generate somehow the URIs for the RDF that is produced. So how do you do that? How does TripleGEO do that?
Okay, thank you for the question, Robert. So, in order to have URIs that are maybe global, unique, and well-formed, TripleGEO provides you with the facilities and the underlying ontology that you can use in your spec, in your mapping spec. So there are built-in functions that can combine parts of the original dataset. For example, the file name, the ID, the identifier of each feature, and construct URIs this way. Also, URIs of, let's say, of entities that are linked to the main entity are constructing using a path approach so that no blank nodes exist. Also, there are other alternatives. It's up to the user to choose whether such an approach is needed. Maybe a random approach using UUIDs may be needed. But there are these facilities to construct it based on attributes of the original URL, of the original row, the original feature, using built-in functions. Yeah, that's more or less it.
Okay, thanks. So it's quite flexible. I have different possibilities to construct the URIs, which is good.
Exactly.
I see a raised hand here. So Valentina.
Hello, everyone. Thank you for very interesting presentation. These are very interesting tools. Yeah, I can ask many questions now, but maybe to ask Harry about the tool. So it's very interesting. I see the applicability of the tool really useful, but I have the following concern. So I have a semantic web background. I've done RML visually, but not programmatically in pure text format. Oh, so I'm okay. Let me put the question in this way: do you plan any user interface for the tool? So for many users, it would be much easier to use a user interface rather than command line. And I'm saying that from experience where I have the suitable background to do these things. And I know many users don't have the semantic web background that I have. Potential users could not have that background.
Yeah. So Valentina, thank you for the question. Actually, the first part of my answer would be that TripleGEO has been designed as a command line utility. So a user interface was not in the plans. The second part of my answer is that since RML is really tedious to write, this is the reason that another approach, the YAML approach to defining the mapping has been developed. That is much easier to read and write. And YAML in general as a format is used for making things humanly readable and also for computers to handle and process. So yes, we don't have a user interface in our plans, but there is also a more readable way, a humanly readable way to provide our mappings. I hope this covers you.
Yeah, I understand. So I see your point, and I fully understand your point. I just wanted to mention that user interface helps really the how to say the adoption of tools. And it's good you provide YAML alternative to RML. Yeah. But in a way, it's still mostly for users with a certain background rather than more general user base, to say.
Yes, that is
Thank you.
correct.
But I have the tool in mind in case I need to use similar transformations. Thank you.
Thank you too.
Thank you. I have another question about TripleGEO, about the classification schemes. So how are they made available to the RDF representation?
Okay. Actually, this is I guess this is much easier than the mappings. And the fact is that you have a hierarchy of classes in a classification file with, let's say, in a CSV file like the one we saw. And in your feature, you have a thematic attribute that uses one value from this classification. In order to have the whole information available in RDF format, the whole classification is transformed to RDF format where the hierarchy is represented by, let's say, parent-children, parent-child associations. And then you have the whole hierarchy. And then when it comes to the specific feature that is transformed into RDF, you have the property that links to the one leaf, possibly, yeah, leaf entity of the hierarchy that this specific feature has as a value, as an attribute. Okay, so you have the whole hierarchy in RDF, and you have the specific triple that links the feature to the value.
Mm-hmm. Mm-hmm.
Class.
Okay. Mm-hmm. Thank you.
Thank you too.
Okay, any other questions? Okay, I have a question about JenPlane. So thanks again for the nice demo. We saw how to bring a new tool into the toolbox, providing the URI. But what are actually the requirements for a tool, an application to be compatible with the toolbox, to bring it technically into the toolbox?
Okay. I can answer it in two parts. One is that what is needed architecturally to be done, and one is that how it should be packaged to be able to be consumed or to be ingested in. The first thing is that we don't really care about the language or the technology or architecture of the internal of the tool. The only thing is that we impose some sort of an accessibility layer on top of it, which means that everything that you have inside the tool must be exposed to the outside world through REST APIs. REST APIs, we are supporting Open API specification 3.x, whatever, like 3.1 and so. So you should be able to write this API surface, and also you should be able to actually to serve these APIs when they are requested. So how do you do it internally? We don't care. But the interchange with the rest of the JenPlane tool ecosystem is through this API specifications. This is one thing. The second thing is that you have to have also a manifestation file, which is an RDF in TTL format that is describing what is your tool, what are the services, or we call them operations, what are the services that your tool provides, and also what is the cost of executing those operations, like cost in terms of energy, cost in terms of time, like time duration, and cost in terms of licensing. Like, for example, one of your operation can be licensed only for a specific community, or can have like a monetary cost around it, or some of them can be free. So, and then you have to package this onto a GitHub or GitLab repository, containerize it, and then provide us with the URL of that, basically that repository. So we will check the TTL file first, and then check if there is a container there, if that container is already registered and pushed to a registry, and if the naming and versions are compatible to each other. In that case, we ingest it into the tools, and then people can use it in their processes, so that we can recommend it to the processes.
Okay, thanks. So JenPlane will then assemble the workflows, right, based on the tools and the criteria automatically. And we saw that you did an Argo integration, but what is actually required generally to run the whole workflow system?
Okay, so as I said, the workflow by default assumes that each step of the workflow will be run by a different tool. And also tools are developed by different companies, different groups, and so on. So the package or the unit of packaging for us is a step, and unit of each step execution is a tool, which for us is a container. So in general, our workflow is a multi-container orchestration system, which means that we have to be able to run it on a platform that can run multiple containers and also establish a connectivity for them. So at the moment, we are using Kubernetes for this as platform, because Kubernetes is able to actually to host and schedule and place the containers on different nodes based on their requirements, and also is able to establish a discovery, like if in one step you want to discover a service or discover any other endpoint API, there should be some sort of a naming convention like a DNS service and so on. And also establish a networking between them, so that when you are calling an API of another tool in the next step, you can really reach that step. So all this is provided by Kubernetes. Then on top of Kubernetes, we need Argo workflow runtime system, so that it actually orchestrates the step execution, image pulling from registry, and then asking Kubernetes to run them. So in general, we need at least 3 components. One is a central registry that all the container images are there. We need the Kubernetes that is able to run these containers, and we need Argo to be able to run the flow.
Okay, so the actual workflow is based on Argo.
Right.
And I mean, I guess you will run these workflows probably regularly. Yeah, they represent data processing, of course.
Sure.
Would it also be possible to transfer them to a different installation or share them with someone else?
That's interesting. Yeah, actually, this is very good for those who want to do the preservation phase. If you remember from the JenPlane, there is a preservation phase. At that preservation phase, people usually just preserve the input data and sometimes the output data. What we are going to encourage is that to also preserve the whole flow. So in this case, the whole flow is basically the JenPlane project that you create, which is the RDF. So we give you the RDF document. And in addition to that, we give you the full YAML file of your workflow, so that you can put them side by side, you can share them, you can even send them for execution in another environment. You can have multiple Argo system, like for staging, for testing, for production, and so on, and then do them step by step based on maturity. So is really flexible. It can be even pushed into your GitHub repository, for example. Some other people can take it and reproduce it somewhere else. And one good thing is that everybody, by looking at that, they can exactly know what you have done and whether it was wrong or right or whatever. So it actually satisfies a lot of scientific requirements of reproducibility.
Mm-hmm. Yeah, that's great. And it's really based on standards and very flexible for your reuse. Thank you. Thank you.
Sure.
Okay, do we have any other questions? Okay, I guess this is it, and we can close for today. But as a final comment, I would like to share information for the next session, because we will continue with the webinars. So the next DataBri-X Tool Session will take place at the 12th of December, so quite soon, in some weeks. And there we will look into tools for advanced data annotation and analysis. We will see again several tools which can be used for these purposes. And yeah, thank you for your attention today, and hope to see you next time. Thanks.
Thank you, Robert.